In this video I will show how to build a Chicken Coop sliding doors with a standard servo, or better, a 360-degree servo. This trick I think is the best one in order to use an Arduino or an ESP32 in order to control the motor. The system is based on a rope and a counterweight. And on the servo there is only a rubber wheel. The door can be of any size and almost any weight. It's very convenient because you don't need a limiter switch going up and going down. You simply provide a pulse for a little longer than needed and the servo will spin freely. When it reaches the right position, you can see that here the rope is a little bit floppy and so the motor is not sinking too much current. Going up, the trick is to put a plane so that the rope is remaining floppy here and again the motor is not sinking too much current. Now I will show the mechanical build of the door and a simple electronic implementation for the control board, which is with a Node ESP32. Let's have a look at the mechanical build. Here I'm using just one profile for the entire build with 4 holes. The counterweight weight is the same one of this one, so you will not have anything slipping up or down. On the servo there is only a rubber shaft. It's a sandwich like this one, so with 2 servo arms and something rubbery on the middle. You can use a Lego tire, for instance. In order for the rope to be attached to the door, I suggest to perform just 2 holes so the rope can go in and out again. This prevents the door to get stuck when opening. Let's start with the build. You need to cut 4 C-type of aluminum profile. The length of the taller profile has to be twice than the door size. A little more, twice plus this part, so that the door will be able to swing up and down. The first short profile has to stay between the long profiles, like this, while the upper one has to stay on the top. Once you position everything correctly, you will have to hold it and drill 4 holes at the edges. Now, let's assemble everything in the Chicken Coop. I suggest you to have a prototype with a piece of wood. You need to have 2 slots in order for this bracket to be placed there. This will prevent the servo from moving backward and forward and will enable you to attach the servo completely flat on this surface. And finally, you have to pass the rope on the top of the wheel. That's it. This is the wiring diagram. We have the light sensor attached to the E2C with a pin strip. Then we have the servo, again to a pin strip, and the IO13 with a little wire. And then we have the solar charger attached to the battery port of the board, to a lithium battery and a solar panel. With I think 200 mA you can survive even in cloudy day, but I'm using 500 mA. Let's have a look now at the wirings. This is how it looks like. This is the Node MCU8266, this is the light sensor, this is the battery charger, this is the lithium battery, the servo, and this wire here is going to the solar panel. As you can see, I used a lot of not connected pins in order to place a pin strip and connect the sensors and the servo. This is just to have a mechanical reference. Also here I have 2 non-connected pins where I connected power supply, ground and the signal servo. And you can see it here that with few small wires I'm connecting the not connected pins to a pin strip. This is convenient because if I need to change something, I can unplug this pin strip here. As you can see here, we have an LED blinking. This means that the statue is open. One blink is open, two blinks is closed. In addition, when the light is getting dark, I have a pre-alert with the fast blinking, which means that the door is about to close in 30 minutes. And I will put it on a plastic box in order to resist to the rain and moisture. The plastic box has to be transparent so you can still see the signaling LED. I prefer also to check the LED of the charger, so the charger I will put it in this position so I can still check the two LED for charging. And the light sensor, of course, has to point upward. How does it work? If the light is below a certain threshold, I will start counting for half an hour to be sure that all the chickens are in, and then I will close the motor for, 15 seconds. Everything is a parameter in the source code, we will see it later. If the light in the morning is going above a certain threshold, I open immediately the servo. Here is a quick code walkthrough. For the board, please select the DFROBOT FireBeetle ESP8266 and not the standard one, otherwise you will have issues with the light sleep functions. On this project I will not use the Wi-Fi, it is only a state machine to open and close the door. If you need it, you can probably add it by yourself, because the board is capable of Wi-Fi and Internet of Things. Here, some library that you have to install in order to have the light sensors, the servo and the E2C working correctly. The servo is connected to pin 13. I have two thresholds for open and close the door. Those are light threshold, 70 lux or 6 lux. And then I have a timeout, so if I don't get a light from the lux meter within 10 seconds, I will give up on requesting. Then I have this value is very important, is how long the 360-degree servo will spin when I want to close or open the door. In my Chicken Coop it is 14 seconds to have the door completely open or closed. Then setup. In the setup function, I'm only initializing the serial for the serial monitor. I am initializing the output pins for servo and the LED, and then the E2C interface for the lux meter. And here I'm initializing the lux meter. Then in the loop I will have my state machine, which is very simple. You have a coop state, coop idle, where you are waiting for the lux meter to have a very low threshold or very high threshold. So you will open or close the door. There is a closing and opening status, where you are moving the servo for an open-close duration, which is 14 seconds in my case. Then once it's completely opened the door, you have to have a low threshold in order to move to the coop wait for close. You don't want to close the door as soon as the light is low. Otherwise, your chicken may be still out, or if there is a cloud passing through the lux meter. So it's better to wait for some time. In my case, I'm waiting half an hour before I'm closing the door. And finally, I'm closing the door if the light was remaining low for half an hour during all this phase. Wait for close. Once the time open-close duration is expired, I will move to the state coop closed. That's it. This is the code. Let's check now the power consumption. We have 250 milliamp while the servo is spinning, a little more if you drag with the door. And you have about 2 milliamp when it's in idle, and with some peaks when the LED is blinking. Without servo and without sensor, the current consumption is about 1 milliamp. For a real low power consumption, you should have a circuit to detach the servo and probably go to deep sleep mode. And so this is our solar panel and the chicken coop. Now we will place the controller below here. So this is the door, you see, servo, and this is the mechanism. As I mentioned, I don't have the plate here, but it's working anyway since 1 year now. Let's put all the connectors inside the box, so it is more protected for the humidity. You will find the source code in the description. That's it, thanks for watching.